Okay, now non-homogeneous recurrence relation, continuation of the problem session. Solve an minus 4an minus 1 plus 4an minus 2 is equal to 3n plus 2 raised to n, where a0 is equal to 1 and a1 is equal to 1. So here the solution part, first we have to find the homogeneous solution and then we have to find the non-homogeneous solution. The given recurrence relation is non-homogeneous. So we consider this equation as non-homogeneous because we have 3n plus 2 raised to n function of n. So this is non-homogeneous. Now we find the order of this equation and we can write the characteristic equation using that. So in this equation, order is the highest term, nth term, then the least term is n minus 2. So here we get n minus n plus 2, that is 2. Order is 2. So when our order is 2, we have to start with r square, right? We write the characteristic equation, that is r square, then r, then constant term is equal to 0. So we take the coefficient from the given recurrence relation. Coefficient of a raised to n is 1, a suffix n is 1, then an minus 1 minus 4 plus 4. So you get 1r square minus 4r plus 4. RHS should be 0. Okay, don't take this. We have to characteristic equation RHS is equal to 0. Now you can find the roots. We get 2 r values using your you can use any method or your calculator anyway. You can find the roots. We get 2 comma 2 as the root. So here it is repetition. Okay, when repetition is there, we know homogeneous solution is general form we have learned. Since the roots are real and equal, a and h is alpha 1 r power n plus n into alpha 2 r power n. So you should take a n here when the roots are real and equal, and we have only twice, okay, repeated twice, so we have taken n. If repeated thrice, we have to take n square alpha 2 r power n. So only 2 times it is repeated, so we take like this. Now r is common, okay. What is r? R is 2. So we substitute alpha 1 2 raised to n plus n into alpha 2 2 raised to n. This is the homogeneous solution. Now let us find the non-homogeneous solution, that is the particular solution. So here we have two terms, that is one of the term is 3n and the other one is 2 raised to n. So let me consider 3n first, okay. So we have learned when f of n is n, form of an is c0n plus c1. So we are going to use this because f of n is 3n, right? Our first part, particular integral 1, we can take 3n. So there we have n, 3 is constant, n, we should consider n there. So you take the form for n, 3, c0n plus c1. This is 3 into n, okay, 3 into n. So we take an is equal to c0n plus c1. So what will be an minus 1? We replace n by n minus 1. Here also replace n by n minus 1. c0 n minus 1 plus c1. Next an minus 2. Replace n by n minus 2. Replace n by n minus 2. So c0 n minus 2 plus z1. So now we consider the given equation. This is our question. an minus 4an minus 1 plus 4n minus 2 is equal to 3n. We are not taking the second function. Okay, we just take the first function only. That means together with 3n. And this one we take the next step, that is when we find pi2 we can do that. So now this is pi1, okay, particular solution 1. So we take that and now we substitute these three equations and we are going to find c0 and c1 and we substitute in equation a so that we get particular solution 1. To find an p1 we need c0 and c1. So we substitute an minus 1, an minus 2 in this equation. An is c0n plus c1. And an minus 1 value we have substituted here, an minus 2 value we have substituted here, okay, c0 n minus 2 plus c1, which is equal to 3n. Now let's just expand it. Expansion part you can do, just expand this, take this inside, c0 n minus c0, here c0 n minus 2 c0. Then next step you can take this 4 inside, that means here you take 4 for each and every term. So minus 4c0n, minus into minus plus 4c0, minus into plus minus 4c1. Here also plus 4 minus 8 plus 4. Okay. Now here some of the terms are getting cancelled. Minus 4c0n plus 4c0n. Similarly, minus 4c1 plus 4c1. Write down the remaining term. So after writing the remaining term, we can c0n plus c1 minus 4c0. Here, how do you get minus 4c0? You see, plus 4c0 minus 8c0. Adding these two terms, we get minus 4c0 is equal to 3n. Now equating coefficient of n. So to find c0 and c, we equate it. Coefficient of n is c0. In LHS, n you have c0. Coefficient of n in RHS, it is 3. So c0 is equal to 3. So equating coefficient of n, you take, here there is no n, only one term contains n. Therefore c0 is equal to RHS coefficient of n is 3. Now similarly equating constant term, what is the constant term here? You have c minus 4c0. RHS there is no constant term. We consider this as a equation in n, okay, function of n, f of n. This is equation in n. So constant term means term without n. C1 minus 4c0, there is no n. So we take c1 minus 4c0. RHS, there is no term without n. So we take 0, equate it to 0. So now c0 is 3. Substitute 3 for c0, you get c1 is equal to 12. So after finding c1 and c2, you can substitute it in the equation, that is equation. So we get particular solution 1. Substitute c0 here and c1 here. So an p1 is equal to c0n plus c1. That is, what is c0? c0 is 3. So we get 3n plus 12. An p1 is equal to c0n, that is 3n plus c1 is 12. 3n plus 12. This is particular solution 1. Now let us go to particular solution 2. So f of n is 2 raised to n. So in the we have the second term. What is this? 2 raised to n. So f of n 2 raised to n we have to consider. And whether this 2 is a root of the given equation. Let us verify. We have the characteristic equation, right? So in the characteristic equation 2 is here and it is double root. Okay, 2 power n, 2 is repeated twice. So we call it as double root. So what is the general form here? So here we have a raised to n. A is a double root. Okay. Here a is 2. In our question a is 2. So 2 raised to n, 2 is a double root means what about an? So this is form of an. An should be of the form cn square a raised to n. It should be of the form since a is a double root, cn square a raised to n. So now we assume like this. Since 2 is repeated twice, we call it as double root, okay? So also it is of the form 2 raised to n. So here fn 2 raised to n, 2 is a double root, okay? It is repeated 2 times, that's what I explained it now. In the characteristic equation, 2 comma 2 is the root. So we take it as a double root. And from the table, when it is a double root, it is cn square a raised to n, okay? Cn square a raised to n. A raised to n is here 2 raised to n. A is 2, so 2 raised to n. If you understand this, you can do the remaining part, so simple. Now we have to find c. So let us write a n minus 1, replace n by n minus 1. C n minus 1 the whole square, 2 power n minus 1. A n minus 2, replace n by n minus 2. C n minus 2 the whole square, 2 raised to n minus 2. Okay, here you can replace n by n minus 2. So now consider the given equation. Given equation RHS, you take only the second term, don't take the first. Now we have completed the PI for 3n, right? Now we are taking 2 raised to n. So don't take 3 power n, it is enough you take 2 raised to n. So 2 raised to n, after replacing, this is the equation. Here you substitute the values. an is cn square 2 power n. Then here an minus 1, cn minus 1 the whole square 2 raised to n minus 1. 4 is here. Then 4 into an minus 2 plus 4 into an minus 2 is this cn minus 2 the whole square 2 raised to n minus 2. RHS, that is equal to 2 raised to n. So now let us expand. Before expanding, we can take 2 power n minus 2. You can follow many methods. So the method I am following is dividing by this number, least number, that is 2 power n minus 2. So dividing by 2 power n minus 2, divide each term, okay, first term, second term, third term. Also RHS you divide by 2 raised to n minus 2. So now here you can split the denominator as 2 power n into 2 power minus 2. each and every denominator can be split at 2 power n, 2 power minus 2. And here you can cancel, okay. 2 power n minus 2, 2 power n minus 2 will be cancelled. So you have 1 here. Here you can split 2 power n, 2 power minus 2. Now in the next step, this 2 power n will be eliminated. Also this 2 power n. Numerator also you can split the term. 2 power n, 2 power minus 1. So this 2 power n will be eliminated. Here no term. Here 2 power n will be eliminated. So now taking this 2 power minus 2 to the numerator, 2 square. 2 power minus 2, 2 power minus 1. So what is that? So what is 2 power minus 1 by 2 power minus 2? 2 power minus 1 into 2 power 2. Okay, when 2 power minus 2 goes to the numerator, it is 2 power 2. That is 2 power 2 minus 1, that is 2 is the answer. 2 power 1, that is 2. Or you can take 2 square by 2 also. When this goes to the denominator by 2, anyway it's 2, okay. Answer is 2 here. So we will substitute it. Here you see 2 power, this will become 2. So you get 2 here. And here you take this to the numerator, 2 square. Now expansion part you can do. Write the remaining term a minus b the whole square expanded. In both the case you can expand, okay. Here 2 4s are 8. 2 square is 4. Here 2 square is 4. Expand this using a square minus 2ab plus b square. A square minus 2ab plus b square. Expand it. So these two terms are getting cancelled. So you can write the remaining term 4 plus 4 8 cn square minus 8 cn square. Then here minus 8c plus 16c plus 8c is equal to 4. Now cancelling 8c is 4, c is 1 by 2. So after finding c you can substitute it in equation. Equation b is this. So we get a and p2, okay. Now you can substitute the value of c. Cn square 2 raised to n. C is 1 by 2. So you get 1 by 2 n square 2 power n. So now what is the general solution? We have 3 solutions here. That is an homogeneous solution, an particular solution 1, an particular solution 2. So you can write that answers together. This first term is an homogeneous, this is pi1 and this is pi2 and this is equation number 3. Now we have two initial conditions. Given a0 is equal to 1, so n is 0. So you substitute n 0, you get 2 power 0, here 2 power 0, this term will become 3 into 0 is 0. Here also when it is 0, 1 by 2 into 0 it is 0. So you get 12 and the remaining terms. This term will become 0. 0. N is 0. 0 into any number 0. So alpha 1 2 power 0 plus 12. Alpha 2 power 0 is 1. So you get this alpha 1 is minus 11. Now a1 is equal to 1. This is also given in the question. Therefore n is equal to 1. So here instead of n you can substitute 1. Okay. So when you substitute 1 for each and every n you get an equation. So here you substitute alpha 1 is minus 11. You can substitute alpha 1 value and you find alpha 2, that is 7 by 2. Okay. You can do the simplification part. That's very simple. It's something that you learned in the school. So you can substitute alpha 1 value instead of this one. Solve to find alpha 2. You get 7 by 2. Now the general solution is, because now we know what is alpha 1 and alpha 2. So you can substitute it here. This is the general solution, right? After adding all the solutions, you instead of alpha 1, alpha 2, you substitute the given value. That's what initial condition is for, right? So using initial condition, alpha 1 is minus 11, alpha 2 is 7 by 2. So substitute it here to get the solution. This gives the solution of the given non-homogeneous recurrence relation. So here you have two questions. You can try these questions on your own. Okay.